Welcome, Mr. Sutton here with the AB Calculus 4-2 Extra Practice Number 3 solutions on increasing and decreasing intervals. For this problem, we're trying to figure out where this polynomial is increasing and decreasing. To do that, we're going to find the derivative, find some critical values, and do some sign analysis. So y prime on this one, that's going to be 3x squared plus 4x, and I want to know where this thing equals 0. So to figure that out, I can take out an x, leaving me with 3x plus 4 inside. And I see that I have critical values then at x equals 0. And if we subtract 4 and divide by 3, that's going to be negative 4/3. So let's set up a number line, an f prime line if you will. We've got critical values again at negative 4/3 and 0. Now we're going to test each of these intervals around those. So for negative 4/3, I'm going to try something a little bit less than that, like negative 2. Plugging that in this factored version of f prime, that's going to be a negative times, let's see, 3 times negative 2 plus 4, that's also negative. So negative negative gives me a positive. And then something between negative 4/3 and 0, how about negative 1? So that's going to be a negative and a positive gives me a negative. And then something bigger than 0, let's try positive 1. So that's positive times a positive is a positive. Now I can figure out increasing versus decreasing. Since f prime is positive in the first and third intervals here, I can say that f is increasing from negative infinity to negative 4/3, union 0 to positive infinity. And since f prime is decreasing on this middle interval, or f prime is negative rather on this middle interval, we know that f is decreasing from negative 4/3 to 0. For this problem, we're trying to figure out where this function is increasing or decreasing. So let's start by finding the derivative and some critical values. We've got negative 4x to the third, followed by 6x. And I'm going to set this equal to 0 and solve for x now. So I can factor out a 2. A negative 2 actually. That'll leave me with 2x squared minus 3. And then, let's see, I see here that x has to equal either 0, or if we add 3, divide by 2 and square root this, plus or minus 3 over 2 inside a square root. So that's 3 critical values for us to test around. Let's go ahead now with our f prime number line. So we have negative radical 3/2, 0, and radical 3/2. Something in the far left corner here, less than this, that would be like negative 2 I think would work, because this is about 1.5 and the square root of that isn't going to be as far out as 2. So let's try negative 2 over here. I'm going to use this factored version. So plugging in negative 2 in the front, that's going to give me a positive. In here, 2 times negative 2 squared minus 3, that's also a positive. So positive overall. And then, let's see here, number in between negative radical 3/2 and 0. Negative 1 would work. So that's going to be a positive. And this is going to be now basically 2 minus 3, which is a negative. So negative overall result. And then let's try positive 1 in this next interval. So that's a negative out front and a negative inside, gives me a positive result. And now this last interval, let's try 2. That's going to be a negative in front and then a positive inside, so negative overall. All right, since f prime is positive in the first and third intervals, that means that f is increasing from negative infinity to negative radical 3/2, union 0 to positive radical 3/2. And since f prime is negative on the second and fourth intervals, f is decreasing from negative radical 3/2 to 0, union radical 3/2 to infinity. To figure out whether this function's increasing or decreasing, we're going to take the derivative and find critical values and do some sign analysis. Before I do that though, let me rewrite this as negative 3 parentheses x minus 3 to the negative 1. And now using the power rule, the derivative of this is going to be 3 parentheses x minus 3 to the negative 2. And if x minus 3 had a derivative other than 1, we'd multiply by that. But it doesn't, so we'll just leave things the way they are. Now to solve this for critical values, it's easier if you put this back in fraction form. So I'm going to write this as 3 over x minus 3 to the second power. And now for critical values, I'm looking for places where this fraction is either 0 or undefined. Now, since this fraction has a constant in the numerator, it can never equal 0, because you would have to have a 0 in the numerator to get 0 out of this. However, the f prime does not exist if x equals positive 3. That would 0 out your denominator. Now, before you go ahead and stick this on a number line and do sign analysis, take another look at this fraction. The numerator is positive. The denominator has to come out positive because you're squaring whatever you plug in there. So this thing is actually going to be positive as long as x does not equal positive 3. Therefore, this function is going to be increasing. F is going to be increasing from negative infinity to 3, union 3 to infinity, basically increasing everywhere except for 3. In terms of decreasing, well, it's never negative. F prime is never negative, so that means that f is decreasing nowhere. On this problem, we want to know if this function is increasing or decreasing and where that's happening. I'll start by taking the derivative and finding some critical values. So this is really a negative something to the 2/3 sort of situation. Derivative of that is going to be negative 2/3 to the something, or times something to the negative 1/3. But then we're going to have to multiply by the derivative of the something, the 4x plus 12. So that derivative is going to be a 4, tail of 4 here. I'm going to put this all together and kind of simplify it, just so it's easier to find critical values once I finally set this thing equal to 0 and solve. So I have a 4 times a 2. That's going to give me an 8 in my numerator. I have a 3 in the denominator. Also in the denominator, I'm going to have the cube root of 4x plus 12. So in total then, that's negative 8 over 3 cube root of 4x plus 12. And now for critical values, I want to know where this fraction is either 0 or undefined. Well, since we have a constant numerator, this can't be 0. So it's undefined or nothing. I'm taking a look at our denominator. So with the cube root, it's okay to take the cube root of negative numbers. That's fine. But if we have 0 in the denominator, that would still be a deal breaker. So if you have negative 3 as your x value, that would 0 out this radical, which would also 0 out everything in the denominator. So we see that this function, this f prime, does not exist at x equals negative 3. So we're going to make a number line, an f prime line here, and we'll stick number negative 3 on there, and we'll test around that in terms of looking for the sign of f prime. So something less than negative 3, let's try out, let's see, here what would be a good number to test out? I don't know. Let's go with negative 4 and see what happens. We could always pick another number if that doesn't work out so well. So we've got 4 times negative 4. That's going to be negative 16. Plus 12 is going to come out to a negative number. The cube root of that's going to be a negative number. Multiplying by 3, still negative. But then the whole thing becomes positive because of this negative out in front. So positive overall result. And then if we plug in something bigger than negative 3, I'm going to go real easy here and go for 0. So you plug 0 in here. Now you're cube rooting a positive, which keeps the denominator positive, but the whole fraction is negative, so that's a negative overall result. Based on f prime being positive over here, we can say that f is increasing from negative infinity to negative 3. And then since f prime's negative on this interval, then f is decreasing from negative 3 to positive infinity. For this problem, we're analyzing where this function is increasing or decreasing, which means we're trying to figure out where f prime is positive or negative. So let's figure out f prime, find some critical values, and do a little sign analysis. F prime on this is going to require us to use the quotient rule. So let me use my box and ribbon to help negotiate that. I've got my numerator, x squared, denominator, x plus 1, and the derivatives of those, which are 2x and 1. Using my ribbon to multiply it all together, we've got 2x times x plus 1. So that's going to be 2x squared plus 2x if I distribute that out. And then going the other way, we've got minus x squared. All over, this will be x plus 1 quantity squared. And then simplifying this a little bit, that's really going to be just x squared plus 2x if I combine those x squareds. All right, so I need to know where this thing is either 0 or undefined. So I'll set the whole thing equal to 0, but really I'm only looking to see where the numerator equals 0, because if you 0 out the numerator, you're good for the whole thing, unless you also 0 out the denominator at the same time. Hopefully that doesn't happen. So for my numerator, when I set this equal to 0, I'm also going to factor out an x just to begin the process of solving. So that leaves me with an x plus 2 inside. And we see here that x could equal either 0 or negative 2. Either of those will be critical values. Now we also see that f prime is going to be undefined at x values like negative 1. So since we're not defined, does not exist at negative 1, that is also a critical value that we have to test around. So let's put all this on a number line, and I'll just label that with an f prime. There we go. Now people know what they're looking at. So we've got our critical values at negative 2, negative 1, and 0. And we're testing values around those. So something less than negative 2. Let's try negative 3. Now I'm going to use this, let's see, I'm going to use this fraction form, but I'm going to use this factored version as well. Actually, I only need to use the x times x plus 2, and here's why. X plus 1 squared, that has no choice but to come out positive. So it's not going to affect the sign. What will affect the sign then is completely whatever happens in this numerator, which in factored form is right here. So plugging negative 3 into just the numerator here, we've got a negative times a negative, giving me a positive. And now something between negative 2 and negative 1, like negative 1.5, that's going to be a negative and a positive, comes out negative. Now between negative 1 and 0, how about negative 0.5? That's a negative times a positive, still negative. And finally, bigger than 0, how about 1? That'll be a positive, positive, comes out positive. All right, since f prime is positive on the outside intervals here, we can say that f is increasing from negative infinity to negative 2 and from 0 to infinity. Since f prime is negative on these middle intervals, we can say that f is decreasing on negative 2 to negative 1, union negative 1 to 0. Now you might be wondering, well, could I just say from negative 2 to 0? Sometimes you can, but this is not one of those problems. Because the original function is undefined at negative 1, you are not allowed to include it on an interval of decreasing or increasing, even though it's a border value. For this one, I want to know where cotan is increasing or decreasing, and this is the interval from negative pi to pi. So to help me on this, I'm going to take the derivative and find some critical values. So that would be negative cosecant squared of x. And I'm going to rewrite this as 1 over sine squared of x, because that's really what cosecant is 1 over sine. And we're going to see where this thing equals 0, or undefined. Now, with the 0 issue here, since you have a constant in the numerator, it can't equal 0. So that means that our only choice is to somehow make this thing undefined. So we're basically asking what values of x, if I plug them in for sine, in between negative and positive pi, what values are going to make sine squared come out to 0? Well, sine is 0, the y value is 0 on the unit circle when you are at pi or negative pi or 0 or 2 pi, any of those. So in terms of the interval, we're going to say that f prime is undefined because sine is 0 at negative pi, 0, and pi. So those are some potential critical values we have to test around. Now, since negative and positive pi are the endpoints of this interval, we don't need to test anything to the left or to the left of negative pi or to the right of positive pi. So really, we're just testing between these and 0. And there's actually a little bit more going on here. Since this denominator comes from squaring something, the denominator of this fraction can't help but be positive. It's always going to be positive. 1 upstairs is also always going to be positive. And because there's a negative out in front, the entire fraction is always going to be negative. So with the exception of these critical values, for all other values, f prime is going to be a negative quantity. And again, we'll specify this is true for x not equal to negative pi, 0, and pi, at least within this interval. There's more, but we'll just list those. So therefore, since f prime is always negative unless it's undefined, that means that on these intervals, f is going to be decreasing. It means there's no increasing intervals for f, and f is going to be decreasing from negative pi to 0 and from 0 to positive pi. On this problem, we just want to know where this cubic function is increasing or decreasing. So let's take the derivative and do some sign analysis. We've got negative 3x squared plus 4x, and that negative 1 gets differentiated away. Setting this equal to 0 and solving now, I can factor a negative x out of here, leaving me with 3x minus 4. So that means that x is going to equal either 0 or positive 4 over 3 if I solve that equation. And then that gives us some things to test on our number line. So here's an f prime number line. We've got 0. We've got 4/3 as my critical values. And now I'm just going to plug these things into this factored version of f prime. So something less than 0, let's try negative 1. That gives me a positive, a positive times, let's see, 3 times negative 1 minus 4 is negative. So that's a positive negative gives me a negative overall. Now something between 0 and 4/3, how about 1? That gives me a negative times another negative, so that's positive. And then something bigger than 4/3, like 2, that's a negative times a positive, which comes out negative. Since this middle interval is positive for f prime, that means f is increasing from 0 to 4/3. And the other two intervals being negative for f prime means that f is decreasing from negative infinity to 0 and from 4/3 to positive infinity.